Hello everyone, welcome to our session. Let's dive straight into the heart of our topic today, which is the foundational framework your business needs to take AI from a cool experiment and scale it across an entire corporation. This is the Microsoft Foundry methodology. Formally speaking, Microsoft Foundry for generative AI is defined as an enterprise-grade architectural framework and structured engineering methodology that standardizes the lifecycle of artificial intelligence solutions from initial ideation and sandboxed prototyping to production deployment, cross-functional orchestration, and continuous value optimization. In simple terms, Microsoft Foundry is the master factory assembly line blueprint for your company's AI projects. Instead of letting individual departments go rogue and build random uncoordinated chatbots that don't talk to each other, Foundry gives you a single disciplined system to take a small technology idea and safely transform it into a massive standardized engine that runs across thousands of computers globally. Think of it like a global fast food franchise designing a brand new kitchen layout. They don't just guess where to put the ovens or let every local branch buy different equipment. They design a master blueprint down to the millimeter, test it in a laboratory, and then stamp that exact layout across thousands of locations to guarantee identical speed, safety, and quality. I remember working with a massive logistics firm a couple of years back. They had a brilliant team in their Chicago office create an AI tool that summarized shipping invoices. It saved that single office 10 hours a week. The problem was when they tried to copy that tool and give it to their branches in London and Tokyo, the whole system choked and crashed because they didn't have a standardized blueprint for how the data should flow or how the servers should handle the load. They had an isolated victory but zero scalability. Stay with me here because you've probably seen this chaotic tech sprawl at your own office, where different branches roll out conflicting software solutions that cost a fortune but don't connect. Microsoft Foundry fixes this by creating a reliable conveyor belt for your AI initiatives, ensuring that every tool you build is structured to handle real enterprise-grade volume from day one. So, now that we've mastered what Microsoft Foundry means as an industrial framework for scale, you might be wondering about the very first stage of this assembly line, where we bring stakeholders together to pick the right problems to solve. Well, that brings us right into our next step, which is exploring the envisioning and ideation phase. When we step onto the very first station of the Foundry assembly line, we enter the envisioning and ideation phase. In textbook language, the envisioning and ideation phase is formally defined as the collaborative cross-functional discovery stage, where business executives, legal compliance officers, and cloud architects systematically identify high-value operational use cases, define transformation scopes, and establish baseline return on investment projections. In simple words, this is the corporate brainstorming room where you bring the money people, the law people, and the tech people together at the same table to decide exactly what problems we are going to solve with AI before a single line of software code is written. This phase stops your developers from wasting months building a tool that the legal team will instantly ban due to privacy risks, or that the business managers don't actually want. Think of it like an architect sitting down with a family before building a house. You don't just start pouring concrete into a muddy field blindly. You draw sketches, discuss the family budget, map out how many rooms are needed, and check the local town building codes first to make sure the project is actually legal and feasible. Let's break this down together with a dummy example you've probably seen at the office. Imagine a customer billing department where workers handle thousands of invoice disputes a day. Each worker has to manually read an angry email, open an old accounting database, find the receipt, and draft a response. It takes 20 minutes per email, and the staff is completely drowning in red tape. In the envisioning phase, you bring the billing manager, an Azure cloud architect, and a data privacy attorney into a room. The tech person says, "We can use an AI model to read the email and grab the receipt." The legal person says, "Great, but ensure the customer's credit card number is blurred out for safety." The finance person calculates that automating this single step will save 40 hours a week per worker, returning $100,000 to the department budget annually. You log this as a premium, low risk, high value target for automation. You aren't playing with technology for fun here. You are building a structured business case that links software metrics directly to corporate profitability. So now that we have mastered how to safely select and frame our automation targets in the boardroom, you might be wondering about the next major step in the assembly line, where we build a rapid, low-cost working model to prove the concept. Well, that brings us right into our next step, which is exploring the rapid prototyping and minimum viable architecture phase. Once the boardroom gives the green light, we move to the next engineering station, which is the rapid prototyping and minimum viable architecture phase. Formally speaking, the minimum viable architecture, or MVA, is the engineering stage where a limited functional model deployment is rapidly constructed within a sandboxed cloud environment to validate technical feasibility, verify data pipeline readiness, and test baseline output accuracy. In simple language, this is where we build our early working model, or our test car. You don't try to build the final, perfect, ultra expensive enterprise system that connects to every computer in the company on day one. Instead, you build a quick, stripped down version inside a closed digital sandbox that does one single job perfectly. Like reading a sample invoice and pulling out the total amount due. So you can prove to the executives that the AI engine can actually talk to your company's database without breaking anything. It's exactly like a high-tech aviation company building a small wood and plastic scale model of a new jet fighter and putting it inside a wind tunnel to check the aerodynamics before they spend hundreds of millions of dollars building the full-sized supersonic aircraft. Let's use our customer billing example to see how this works. Instead of changing the software for all 1000 billing agents across the global corporation, your development team sets up a secure, isolated Azure testing sandbox. They ingest a small batch of 100 historic, fake invoice emails from the previous year. Using a low-code tool like Copilot Studio, they assemble a prototype bot in 48 hours that is instructed to read those specific files and generate a compliance scorecard. You run the test and the prototype successfully extracts the correct receipt numbers in 85 out of 100 cases without any system lag. You pull the skeptical chief financial officer into the lab, run a live demo on your laptop screen, and show them the exact code metrics proving the concept works. Stay with me here because this phase keeps your transformation team lean, eliminates guesswork, and protects your corporate capital from getting trapped in endless expensive development loops. So, now that we've proven our technical concept works beautifully inside a small testing sandbox, you might be wondering how we scale that small success up into a massive global system that handles millions of live transactions simultaneously. Well, that brings us right into our next step, which is analyzing the enterprise operationalization and scale out phase. Now that our test car has cleared the laboratory wind tunnel, we are ready for the big stage, which is enterprise operationalization and scale out. In textbook language, enterprise operationalization is defined as the architectural stage where a validated AI prototype is migrated onto production cloud infrastructure, integrated with core enterprise applications, and wrapped in strict security monitoring and load balancing systems to support widespread organizational use. In simple terms, this is where we take our test car out of the private laboratory and launch the full-sized vehicle onto the high-speed public highway. This is the moment where you hand the project over to your professional cloud infrastructure engineers to scale up the data pipes. You move the system out of its quiet testing sandbox and deploy it across your live corporate cloud networks, setting up automatic security controls, usage limits, and fallback servers to ensure that if 10,000 employees all ask the AI a question at the exact same time at 9 a.m. on Monday morning, the system stays blazing fast and never stutters, lags, or crashes. Think of it like transitioning a local city water well into a massive metropolitan water grid. You don't just change the size of the bucket, you add heavy electric pumps, wide steel storage tanks, and advanced filtration networks to ensure clean water is delivered to every single building in the city simultaneously with perfect pressure. Let's break this down together with a dummy example from global operations. When you scale out the billing assistant for the whole company, your engineering team configures the system to run on Azure provision throughput instances. This means Microsoft dedicates specific exclusive server hardware in the cloud to your company, guaranteeing that when the end of the month billing peak arrives and millions of data tokens flood the system, Your software has the raw horsepower to clear the transactions in seconds. You also link the tool directly into your master corporate database backbone, ensuring that the moment an agent reviews an AI draft, the live record updates automatically across your global network. As an AI transformation leader, your focus shifts here from purely technical code validation to massive operational reliability, infrastructure cost management, and structural data security. So, now that we've scaled our system up across the entire global infrastructure, you might be wondering how we continuously monitor and polish the engine's behavior to make sure it stays efficient. Well, that brings us right into our next step, which is understanding continuous optimization and review. Once your massive enterprise system is live and running across the globe, you enter the next critical station on the Foundry production line, which is continuous optimization and governance review. Formally speaking, continuous optimization is defined as the systematic post-deployment monitoring phase where an organization tracks system accuracy, token economics, computational latency, and user feedback metrics to continuously refine models and eliminate operational drift. In simple words, this is the ongoing maintenance check and tune-up for your active AI engines. Just because you have successfully launched a massive system doesn't mean your job is finished. You must treat your AI like a living machine that requires regular oil changes and tire rotations to stay at peak performance. You set up automated monitoring dashboards that track exactly how many tokens the machine is consuming, how fast it is responding to workers, and how often human operators are forced to step in and correct its drafts. It's exactly like a flight operations manager tracking a fleet of commercial aircraft over months of continuous service. You don't just watch the planes take off, you continuously audit the fuel efficiency logs, analyze engine telemetry, and adjust maintenance schedules to ensure every single plane stays incredibly safe and perfectly cost-effective on every route. Let's break this down together with an office example. After 60 days of running our automated billing tool, your continuous optimization dashboard flags an unusual metric. The cloud compute costs are creeping up by 12%, and the system response time has slowed down by 2 seconds. You drill down into the data logs and discover that because users are typing longer, more conversational questions into the prompt box, the system is burning extra tokens unnecessarily. To fix this, your team tweaks the background prompt templates, adding a strict instruction that forces the model to compress its reasoning steps, and swaps out a heavy model for a smaller, lightning-fast model tier to handle the simple inquiries. Instantly, your processing speed snaps back to normal and your monthly cloud bill drops by 30%. Your ongoing governance is what separates a short-term technology trend that bleeds cash from a permanent pillar of corporate profitability. So, now that we've mastered how to safely ideate, prototype, scale, and optimize our systems using the complete Microsoft Foundry lifecycle, you might be wondering how you tie all these individual stages into a single, unified roadmap for your certification exam and your executive career. Well, that brings us right into our final step, which is your master synthesis, the Foundry scaling standard. We have arrived at our final milestone, which is the complete synthesis of our journey, the Microsoft Foundry Enterprise AI Scaling Standard. In textbook terminology, the scaling standard is defined as the comprehensive operational framework that unifies cross-functional envisioning matrices, minimum viable prototypes, load-balanced cloud infrastructure, and continuous metered optimization loops into a repeatable governance standard to drive permanent enterprise-wide value. In simple language, this is your master strategic playbook and official corporate compass for technology rollouts. This entire chapter has shown you that scaling artificial intelligence is not about writing a single clever script or turning on a loose web plugin. It is about building a disciplined, multi-layered factory assembly line that transforms raw data and business problems into predictable corporate capital. On your AB 731 exam, Microsoft is going to test your instincts as an executive leader by throwing complex, stressful corporate case studies at you. They will paint a picture of a company facing severe financial distress, project abandonment, or complete system failure because they allowed separate departments to spend millions building uncoordinated, ungrounded AI applications with zero unified lifecycle strategy. Your shield against these exam traps is your complete mastery of the Foundry roadmap. When you sit in front of the test proctor or when you stand in front of your real corporate board of directors, you must always select the answer that enforces this strict lifecycle discipline. Always demand cross-functional ideation filters to secure data safety and ROI before any development begins. Always mandate lean prototypes inside sandboxed environments to prove technical feasibility early. Always deploy on load balanced dedicated cloud infrastructure to protect performance velocity at scale. And always leverage continuous automated dashboards to prune away token waste and keep your systems perfectly aligned with the changing needs of the business. Walking through this computational and strategic landscape ensures you don't just walk away with a passing score on your certificate, but with the rare elite instincts of a true AI transformation leader who is fully primed to step into any corporate boardroom in the world and safely guide its people, its processes, and its technology triumphantly into the future.